Hello, hello, and welcome to a new chapter, that is real number, class class 10, chapter number 1, real number. We'll start with few examples. We have 3 to 4 examples first, and then we'll start with solving questions for this chapter. See, if 4 to the power n is a natural 4 to the power n, where n is a natural number, and we have to check whether there is any value for n for which 4 to the power n ends with digit 0. So we have to check whether there is any value of n for which 4 to the power n ends with digit 0. See, this is 4 to the power n. This can be written as 2 to the power 2 whole to the power n. So this is 2 to the power 2n, and 2 to the power 2n will not end with 0. Why? Because for any number to end with 0, it must have 5 in it. So 2 to the power 2n doesn't have 5 in it. So this is not divisible. Does not have 5 in it. So this number will not be divisible by 5. This is using fundamental theorem of arithmetic expression. Now, next question. Next question, example 2. We have to find LCM and HCF of 6 and 20. Find LCM and HCF. Find LCM and HCF of 6 and 20 using prime factorization method. So I won't write this again. This is prime factorization method. Using prime factorization method, we have to find LCM and HCF. See, 6 can be written as 2 into 3, whereas 20 will be written as 2 into 2 into 5. So this is prime factorization. Now LCM of 6 and 20 will be, LCM is the highest part taken. See, this can be written as 2 to the power 2 into 5, and this is 2 to the power 1, 3 to the power 1. Once we have to find LCM, we will pick the highest part. So 2 ka highest part is square. So 2 square into 3 ka power 1, 3 into 5. So this is LCM for 6 and 20. So 15 4 is 60. And HCF for 6 and 20 is 2. We have find this. Now further, next question. Before moving to the next question, remember this formula. For any positive integer a and b, LCM of a and b into HCF of a and b will be equal to a into b. So this is the formula. We'll need this formula while going through this chapter. So we'll proceed with question third question. This third question is, find LCM and HCF of 96 and 404. Find the HCF of 96 and 404 by prime factorization method, hence find LCM. HCF of 96 and 404 using prime factorization method, PF method, and also find LCM. So see, this is factorization. While solving through prime factorization, we'll factorize this. This is the division method, factorization method. This is 24. Again, this is 12. This is 6. Now this is 3 and this is 1. So 96 can be written as 2 will be written 5 times. This is 32 into 3. So this is 2 to the power 5 into 3. And next is 404. So 404, here it is. 404. Have you heard of 404? In few cases, when in computer code, status error 404 error, when page is not found, computer used to say this is error code 404. So see, 404 will be written as 2 into 2 into 101. So you can write this as 2 square into 101. So you have these two. We have to find HCF. So HCF for 96 and 404. How to find HCF? While going for HCF, we pick the common one. So see, 2 to the power 2 is common in these two. So HCF will be 2 to the power 2. 101 is prime number. This is also prime number. So this is only the HCF 2 square, that is 4. Now LCM. For LCM, we have 96 and 404. So 96 and 404. In LCM, we'll pick the highest part. 2 to the power 5 multiplied by 3, and this is 101. We need to multiply all the components in LCM. Full form for LCM is least common factor, whereas full form for HCF will be highest common factor. So this is multiple, this is factor. So in multiple we have to multiply. So this is 32 into 3 into 101. So this is 96 into 101. Multiply this. So this is 606. This is 909. This is 6, this is 9, this is 6, this is 9. So this is 9696 answer. So this is LCM, we got it. Now we'll proceed with question example number 4. First we'll complete example, and once we complete the example, we'll go for exercise. See, in this question, we have solved this we have find LCM through prime factorization method. If they'll ask to find LCM using HCF, the formula is LCM of 96 and 404 into HCF. See, formula is LCM into HCF is product of number, that is 96 into 404. So LCM of 96 and 404 into product of 96 and 404. So this is LCM, how much? LCM is to be find out. LCM multiplied by 4 equal to 96 into 404. 4 goes out. This is 101. So LCM is 9696, and this is answer. So in these two, this is method 1 and this is method 2. Using this method, we found this type, this answer, and using method 2, we found this. This is prime factorization method. This is formula based solution. So example 3 is done. Now example 4, we will find LCM and HCF of 672 and 120. 672 and 120. 672 and 120. What we'll find? LCM and HCF of 672 and 120. This is question using PF method. PF is not PF is prime factorization method. In short, we can say this as prime factorization. So this is PF. See, 6, 2 into 3, 72. 2 into 2, 4, 4 3 is 12, 12 2 is 24. See, this is 74 upon dividing, this is 37. Okay, uh, 72. So this is 36, and upon dividing, this is 38. This is 9. This is 3 into 3. This is 8 into 9. So this is 2. This is 3 into 3. 2 cube into 3 square. Another number is 120. How will you write it? See, 2 into 2 into 2, 8 3s are 24, 24 5s are 120. 2 ka cube into 3 into 5. So these three numbers are done. We have to find LCM. While finding LCM for 6, 72 and 120, we have to pick the highest part. So highest part, 2 ka highest is 3, 3 ka square and 5. So this is 8 into 9, 72, 8 into 9 into 5. So this is 72 into 5, 360. 360 is LCM. What it will be HCF? HCF for 6, 72 and 120 will be common of these three. So 2 is common in all number and 3 is also common. So 2 into 3, that is 6. So HCF is 6 and LCM is 360. So we have completed chapter examples for this chapter. Now we will proceed with exercise. This exercise, in this exercise we will have multi factor based questions, prime factorization method. So using in this chapter we'll solve questions. These questions are calculation based questions. So first question, express each number as a product of its prime factors. So first number is 140. Have you heard of prime factors, prime numbers? Prime numbers are those numbers which have number factor as number and its own. See, 2 is first prime. So one factor 1 and another factor 2. 5 is a prime number, one factor 1, another is 5. So 3 is a prime number, 1 factor 3, another 1 factor 1, another is 3. So these are examples of prime number. Okay. Using prime number, we have to write factors. 140 is the number. Once we divide, this is 75. This is 5, so this is 7. So see, 140 can be written as 2 into 2 into 5 into 7. So this is 140. Another second one, 156. 156. How will we solve? This is 156. So upon dividing, this is 78, 39, 3, this is 13. Again, this is 70. So this is 2 into 2 into 3 into 13. So this is the expression, prime expression for 156. Now third is 13825. Third is 3825. For 3825, what will we do? Again, same method, 3825. Let's see, 3 plus 8, 11, 11 plus 7, 15, 11 plus 7, 18. So 3, this is 12, 7, 5. Okay, 12 plus 12, 15, this is 425. 6 plus 5, 11. So 5 8s are, this is 4. Again, this is 5, so this is 17. This is 17, so this is 1. So we won't do any mistake. This is 3 into 3 into 5 into 5 into 17. The fourth one is 5005. 5005. So see, this is 5005. Once you'll take comma as 1001. I don't see any further number coming here. 1005 is the number. Once we solve, we get the answer, but while solving, 1001 is a prime number. So if this is prime number, how would we solve it again? Let there be some calculation, and through this calculation we may proceed. 111, this is odd number, so we'll try with 11 or 13. See, 7, we can't solve this through 2, 3, 1, 4. So upon solving through 7, this is 7 1 just 7, 37 4 28, 2 say 21, 11, 11 1 11, this is 13, and while solving 30, this is 1. So 5 into 7 into 11 into 13. Done. Now last question for this is 47429. 74. I hope these solutions are visible. So see, this is 7429. 7429. First, this is rule of divisibility. The rule of divisibility says that if there is 0, 2, rule of divisibility says if there is 0, 2, 4, 6, 8 at end digit. So this number will be divisible by a one number. 0, 1, if any number ends with 1, 3, 5, 7 and 9. This will end with odd number. Now if any number, if sum makes multiple of 3, the number will be divisible by 3. So see, this is 11 plus 2, 13, 13 plus 9, 22. This is not divisible by 3. We can check it by solving, by multiplying as 7. 7 से नहीं हो रहा. 7 see, upon solving this by 17, 17 4 is 68. 17 3 is 51 and 17 7 is 119. Again, we'll pick the 19 one, and 19 2 is 38, 19 3 is 57, and this is 23, so 23 1 is 23. So we have solved this. Now this is 17 into 19 into 23. So this was our first question from this exercise. Now second question is from question number 1 to question number 7. We have simply we have to find LCM HCF only. Question number 2 says find SCF and LCM of the following pair of integers and verify that LCM into HCF is product of two number. So 26 and 91 is the number. 26 and 91. First number we have 26 and 91. We have to find LCM and HCF. Find LCM and HCF. Also verify LCM and HCF. So see this is 26 can be written as 2 into 13 and 96 will be written as 7 into 13. So HCF is the common one. Common number is 2. Common number is nothing but 1. And LCM is 2 into 7 into 13. So 2 into 7 into 13. 14 into 13. 14 4s are 52. And 13 plus 5, 18. So 182 plus 182 is LCM, while 1 is HCF. We have to verify this. How would we verify? I am writing this formula here, over here. See, LCM into LCM of two number multiplied by SCF of two number is product of given two number. For any A, B to be integers. For any two integers, this holds true. So we have LCM 182 multiplied by 1 equal to A is 26 and another is 91. 26, this is 13. 13 is common. So HCF is 13. So 13 2s are 26 and 2 से इसको cross करो 91. 91 goes on. A 1 equal to 1. LCM LHS equal to RHS. So these two is done. So question is verified. So this is verified. Now we will proceed with another one. The second question is find second pair of question 510 and 92. 510 and 92. Five one zero 255 is 17. This is 17 ones are 17. So this is 2 into 3 into 5 into 17. This is 510. And another number 92. 46 while dividing 23. And this is 23 ones are 23. So 92 is 2 into 2 into 23. Solve these two and this can be written. We have to write LCM and HCF. HCF of 92 and 510. HCF will be the common one. क्या है common? 2 is common. HCF is 2 and LCM. It's not easy to write on board. LCM is, it's easy to give lecture. 92 then to write. See 92, 10, 510. LCM will pick the higher number 92 and this is 510. So for LCM we will write this as 2 का cube 3 का पार नहीं है 2 square into 3 into 5 into 17 into 23. So I am writing the answer only. I have already done it. The question is 23460. See, this is 4 into 15 into 17 into 23. 60 into 17 into 23. 17 6 the 17 5 the 115. 17 6 the 102 and this is 23. So 23 0 23 23 to the 46 and 23. So this is 23,460. So HCF is done. LCM is done. We will verify it. So LCM is how much? 2 and HCF is how much? LCM is HCF 2, LCM 23460. Numbers are 92 and 510. Right. So 0 goes out. 0 goes out. 2 6 को cross करो. This is 46 and this is also 13 के table वाला. 13 2 is 0 2. This is 2. 102 102 goes on. 1 equal to 1. LHS equal to RHS. So this formula is done. This is verified. So we have verified the next one. We have verified this chapter second wala, and third we will again proceed with third one. Third is 336 and 54. 336 and 336 and 54. See, this is 336. 16. This is 8. This is 84. This is 42. This is 21. This is 7. And this is 1. So you will write it as 2 into 2 into 2. 3 into 7. This is 336. and another is 54. So 54 will be written as 3, 2 into 2 into 2, 57 into 2 is 54. So this is done. LCM कैसे फाइंड करोगे? This is 54, 336. So this will be nothing but 2 multiplied by 3 का 1 into 7. 2 into 3 that is 6. LCM में हाईएस्ट पार लिया जाता है. 2 इसमें 4 टाइम्स है. 1 2 3 4, तो 2 का पावर 4 होगा. 2 का पावर 4 होगा, 3 का पावर 3 होगा, 7 का पावर 1. तो 16 into 27 into 7, ये 112 into 27. मल्टीप्लाई करिए और आंसर लिखिए. 7 से मल्टीप्लाई करते हैं तो 784 होता है, और 2 से मल्टीप्लाई करते हैं 224 होता है. So 4, this is 12, 9 plus 1 10, this is 3. So 3024 is answer for LCM. Now for HCF, we won't do any rocket science here. HCF is to find the common one. Common one is 54 and 336. So 54 and common number है कितना? इसमें 2 है और इसमें 3 है. So 2 into 3, that is 6. So 6 is HCF. How to verify? For verifying this, we will write 54 into 336 equal to LCM. LCM है 3024 और HCF है 6. देख लो, 6 से इसको क्रॉस करते हैं तो 6 5 जा 30, 6 6 जा 36, और ये 56 है. 56 से इसको क्रॉस कर सकते हैं, 56 नहीं कर सकते, हाफ अप कर लेते हैं. दिस इज 28 and this is 15, 12. Now this is 14 and this is 7, 5, 6. Now 14 5s are 70 and 14 6 are 56. 17 54 54 goes on. So LCM equal to LHS equal to RHS. So 1 equal to 1. So this is verified as well. So 336, this question completed. We will proceed with another one. Question number 3 done. Question number 3rd. LCM and HCF. Find LCM and HCF using following integers by applying the prime factorization method for 12, 15 and 21. 12, 15 and 21. So see, we have to find LCM and HCF using prime factorization method. LCM कैसे फाइंड होगा? पहले प्राइम लिखोगे तो फाइंड होगा. So 2 into 2 into 3 and this is 15. This is 3 into 5. This is 21. 3 into 7. LCM 12, 15, 21 कितना होता है? 2 square 3 into 5 into 7. So 4 3s are 12 into 35. 12 into 35. This is 350 plus 70, 420. और HCF क्या होगा? HCF of these numbers only. कॉमन क्या है? कुछ भी नहीं है कॉमन. 3 है कॉमन. 3 होगा. अब मल्टीप्लाई करोगे वेरीफाई कैसे करना? वेरीफाई करने के लिए देयर इज अ फॉर्मूला टू, so we don't need to verify. So we got the answer. We will match it. Answer 420 is the right one. And another question next is 7, 17, 13, 17, 23 and 29. 17, 23 and 29. 17, 23, 17, 23 and 29. 17, 23 and 59. So these three are prime numbers. क्या होगा LCM? LCM 17, 23 and 29, multiplication of these three numbers. So multiply these three, 23 into 17. 17 threes are 51, 17 twos are 50, 34 plus 5, 39. And again this is 29, so 29 से multiply करते हैं, 9 1 जा 9, 81 plus 81, 9 3 जा 27 plus 8, 35. This is 2, 2 and this is 78. So this is 9, this is 3, this is 13, 10, 1, 11. So 11,339. And for HCF base, make sure what I am writing is visible. Um, Nothing is common. All these are prime numbers only. So I'm not writing. We have solved question up to question number 3. We'll proceed with question 4 and we'll wrap it up. Question number 4 is HCF is given 306,657. 306 306 657. 306 657. These are number. HCF is given. HCF for this number is 9. LCM find करना है. LCM how much? तो number होता है HCF into LCM equal to product of two numbers, that is 306 multiplied by 657. So 9 into LCM equal to 306 into 657. 9 से क्रॉस करते हैं, 9 6 7 जा 63 and 9 3 जा 27. So we will multiply 306 by 73. So this is 918. 7 2 are 52. 7 3 are 42. So this is 8. This is 3. 9 4 are 13. This is 3. And this is 4. So 4 3 3 3 8. This is your LCM. Let me verify. 4 3. Question number 4. 2 3 double 2 double 2 double 3 8. Okay. HCF is given 306 and 657. We have to find LCM. Okay. We have solved it. So see, 7 से multiply करते हैं, 3 3 is 18, 1, so this is 9. 7 से 7 6 are 42, carry 4 and 7 3 are 21, so this is 21. 8 3 9 4 13, 2 2. 22,338 is LCM. This is answer. So we have solved this. Now code is signing. Okay. Question number 5. Next question we have question number 5. Question number 5. It check whether 4 to the power 6 to the power n can end with digit 0. We have to check whether 6 to the power n is divisible by ends with power 0. This will not end with power 0 because see, for any number to end with power digit 0, we need to have 5 in it, and this doesn't have 5. So won't end with digit 0. Question number 6. In question number 6, I won't be able to write these things, but I can explain it very well. See, 7 into 11 into 13 plus 13. One number is 7 into 11 into 13 plus 13, and another is 7, 11, 13 plus 13, and another is this much: 7, 6, 5, 4, 3, 2, 1 plus 5. So once you solve this, 17 plus into 13. So 13 8s are 104, 13 7s are 91. So 91 plus 10, 1014, and this is 6, 24, 120, 120. This is 720 into 7. So 0, 14, 5040. 5040 plus 5. So this is 5045. Right? This is 5045. Now we have to check whether these numbers are prime numbers or co-prime numbers. Okay, let me check whether these numbers are composite numbers. Explain why these numbers are composite numbers. You have heard of, we have learned about prime numbers, composite numbers. In prime numbers, we have only the number factor. Suppose A is prime, so A will have 1 as factor and A as factor. But in composite number, we will have more than 2 number. So see, this is 1014. Once you divide this by 2, we will get 507. Now 507 7 से डिवाइड कर सकते हैं? नहीं हो सकता. 13 से हो सकता है, 11 से नहीं होगा, 9 से, 9 3 से 9 9 5 से 55 नहीं होता, 11 से नहीं होता, 13 से 11, 13 से जब डिवाइड करते हैं 13 3 जा और 11 13 9 जा, ये होता है. फिर 13 से डिवाइड करते हैं 13 3 जा. ओके, सो सी दिस, 3 से डिवाइड करते हैं ये होता है 3 3 जा 9, 3 2 जा 6. ओके, 16 से 11 और फिर 2 से 2, ये 9. 7 प्लस 9 16, फिर इसको 13 इंटू 13 लिखते हैं. और ये 13 है तो यहाँ 1, तो इसको लिखा जा सकता है 1014 को कि दिस इज 2 इंटू 3 इंटू 13 इंटू 30। इसमें इतने सारे नंबर हैं, इतने सारे फैक्टर्स हैं, और ये सारे फैक्टर्स प्रूव करते हैं कि दिस नंबर इज नॉट प्राइम, सो दिस इज composite. Another is 5045. So see, 5045. 5045 is 9 plus 5, 14. So 10009. So you can divide this by 7, 3, 2, 29. 9, 1, 2, 1, 1, 19, 13, 11, 1, 9, 13, 9, 99, 17, 85, 15, 159, 19, 559, 23, 889. Okay, 23, no, you can't solve by 23. Again by 27, 27, you can't say 140 and 49. So this is 27. 27 3 is 81, 140, 14 and this is 9. This is 19. Okay, 27, 7 ja. And this is 37. So this is, through practice you will reach till here. So this is 5 into 27 into 37. So why these two are composite numbers? We got this. The prime difference, the main difference in prime number and composite number is this only. So we have solved. Now another is question number 7. So question number 7 is, there is a circular path. Sonia takes 18 minutes to complete it, to drive one round the field. The last question for this exercise. Again we will solve exercise 1.2 for this chapter. Now this is the last question for this chapter, exercise 1.1. There is a circular field and there is a road around it. So Sonia takes 18 minutes to make one round, and Sonia takes 18 minutes to make one round, and Ravi takes 12 minutes for the same. 18 minutes and Ravi takes 12 minutes for the same. Suppose they both start at the same time, same point, and in the same direction. So after how many minutes will they meet again at the starting point? So this is 18, this is 12. So in such question, we will find LCM for these two, and once we find LCM for these two, we can easily deal with it. We can easily decide एक ही पॉइंट से स्टार्ट हुआ था, एक ही समय पे स्टार्ट हुआ था, एक ही डायरेक्शन में स्टार्ट हुआ था, ऐसे ही गया ये भी और ऐसे ही गया ये भी. सोनिया और रवि दो हैं. सोनिया को 18 मिनट्स लगते हैं, रवि को 12 मिनट. ये 18 मिनट्स वाला है 2 इंटू 3 इंटू 3, और ये 12 मिनट्स वाला है, तो दिस इज 2 इंटू 2 इंटू 3. नाउ वी हैव टू go for LCM. So LCM is 2 का स्क्वायर into 3 का स्क्वायर. So 4 into 9 is 36. Done. So after 36 minutes, Sonia and Ravi will meet in the circular path. So ignore these words. This is important. ऐसा कभी भी क्वेश्चन आता है तो एलसीएम फाइंड कर लेते हैं, और एलसीएम जो पॉइंट आता है वही आंसर होता है. So 36 is the answer. This is all for today. we'll again meet and solve another chapter of NCERT. Here we have started solving NCERT questions from maths for class 10. Once we'll solve class NCERT exercise for class 10th, we will again solve exemplar for this exercise. So stay tuned. We'll again meet again in the next lecture with another topic and another set of questions. That's it. That's all for today. Thank you for watching.